Hello everyone, good evening. Let me know if am I audible.
Yes.
Greetings.
Good evening, Rohit. Okay, so let me share my screen. Today we are going to discuss about organic chemistry. In organic chemistry, we will be focusing on the reactions that are important for your exam. Also, we will be focusing on some questions as well related to the exam. In organic chemistry, as all of you know, the weightage of organic chemistry is increased because deduction of syllabus from the other parts, due to which organic chemistry is very important right now. So I am sharing my screen. We'll be starting with name reactions from all the chapters. First, we will going to start with haloalkanes and haloarenes. So I am sharing my screen. I hope the screen is visible to all of you. Is it visible? Please let me know.
Yes, sir.
Okay. So now, if you see, we are going to discuss name reaction. These name reaction are not only important for your CBSE board exam, but also important for the JEE and NEET examination. How I will let you know with the help of PYQs. So in haloalkanes and haloarenes, we are going to start the first reaction that is known as Sand-Meyer's reaction. In Sand-Meyer's reaction, what we can do, we can prepare chloro, bromo, and cyanobenzene with the help of benzene diazonium salt. So the first question is, what is the diazonium salt? Whenever whenever benzene ring is attached with a group, which is N2, with a positive charge, this ion is known as diazonium ion. As we all know, a positive charge uh, cannot exist alone. So we are going to have here some counter ion. In general, we take that counter ion that as Cl negative. So this becomes benzene diazonium chloride or benzene diazonium salt. This is very important compound for the chemistry of aromatic compounds. So before understanding Sand-Meyer's reaction, we should also know how can we prepare benzene diazonium salt. We will start with benzene. We are going to start with benzene. If we do the nitration of benzene, you know how to do the nitration of benzene? We have to take concentrated nitric acid in presence of concentrated sulfuric acid. So the combination of nitric acid and sulfuric acid is going to produce an electrophile, that is nitro, NO2 positive. When we react electrophile on benzene, we are going to get nitrobenzene. This is the nitrobenzene. Now the next step is to reduce the nitrobenzene into aniline. So we can take here tin with HCl, or we can also take iron with HCl. It will going to convert into aniline. This will going to give us aniline, NH2. And then finally, we are going to do diazotization. In diazotization, we will take the combination of NaNO2 plus HCl. NaNO2 HCl, or in place of NaNO2 HCl, you can also find HNO2, that is nitrous acid. So it is nothing but when we react NaNO2 with HCl, so it is going to produce HNO2 nitrous acid along with NaCl. So here we need HNO2 for the diazotization. This reaction is temperature sensitive, so we need to take care of temperature. The temperature is from 0 to 5 degrees Celsius. And finally, we are going to get benzene diazonium salt. Okay, this is the final product. Now, why I have started this reaction from benzene? Because it is important you to know how to produce diazonium salt with the help of benzene. This can be in the this is going to help you in the conversions. Now, diazonium salt. This diazonium salt, if you check the structure of this compound, here you will find that nitrogen is there, and nitrogen is forming a triple bond with other nitrogen. In neutral state, nitrogen can form 3 bonds, but here we are having 4 bonds, due to which there is a positive charge. Now you see this nitrogen connected with benzene is carrying a positive charge, due to which it is unstable. So to get stabilized, what can be done here? This bond is going to remove. So we can say this N2 positive group is a good leaving group. This as a whole is going to act as good leaving group. If it is a good leaving group, we can have a nucleophile that can replace this group. We need only a nucleophile that is going to replace this group. So we have various nucleophile that can replace N2 from the benzene, and also when nitrogen gas is going to release, it will going to provide stability to the reaction. Why? N2 nitrogen is a highly stable gas. Do you know why nitrogen is highly stable gas? Anyone? Anyone is having any idea why nitrogen is stable? It is also provide inert environment for various reaction. Also, it is sprayed in the chips or food, packet foods. You know why? Because nitrogen is having a triple bond. Nitrogen, triple bond, nitrogen. So the bond energy of this bond is high. High bond energy, high bond dissociation energy, due to which it is highly stable. So whenever a stable product is going to form, that reaction is going to occur in forward direction. That reaction is spontaneous. So what we need to do just in Sandmeyer's reaction in presence of copper ion, copper 1 ion, we will going to take depend on the which type of benzene we are going to prepare. For example, if we need to prepare chlorobenzene, so we will take CuCl in presence of HCl, so we will get chlorobenzene. If we need to prepare bromobenzene, so we will take CuBr in presence of HBr, so we will get bromobenzene. And if we need to prepare benzonitrile or cyanobenzene, we will take CuCN, and the product will be cyanobenzene. And you can see in all the reaction, the side product is nitrogen. So there is a reaction in IIT JEE means that which benzene cannot be prepared with the help of Sandmeyer's reaction. So in option, there is also given iodobenzene. So with the help of Sandmeyer reaction, we can prepare only chloro, bromo, and cyanobenzene. We cannot prepare iodobenzene. Next reaction we are going to discuss is Gattermann reaction. So again, this is similar kind of reaction. Here we are going to take copper in form of powder. Earlier we are taking copper in form of iron. Here we take copper in form of powder with HCl, we will get chlorobenzene. And if we are taking copper with HBr, we are going to get bromobenzene. Here the important part is here to note that in Sandmeyer's reaction, the yield is the percentage of product form is greater than the Gattermann reaction. Now, next reaction is Ball-Schiemann reaction, is especially for anyone is saying anything? Next reaction is Ball-Schiemann reaction. Here, the important part is to note that it is for fluorobenzene and it is two-step reaction. We have to take diazonium salt and we are going to react it with HbF4. So this is kind of ion exchange reaction we have in HbF4, H plus Bf4 negative. So Bf4 negative replaces Cl negative to get ArN2 positive, Bf4 negative, and here side product is going to be HCl. Then we are going to heat this compound. On heating this, we are going to remove nitrogen. Nitrogen gas will remove, and we have BF4. One fluorine will attach to benzene to give fluorobenzene, and BF3 is the another side product. So with the help of Ball-Schiemann reaction, we get fluorobenzene. Other reactions for the haloalkanes, these are the reaction from haloarenes. Now from haloalkanes, name reaction is Finkelstein reaction. Finkelstein reaction is also known as halogen exchange reaction. In Finkelstein reaction, we take alkyl halide Rx. Here, important thing is to note that X can be chlorine or bromine. Only chlorine and bromine we have to take. We are going to react it with NaI. So what is going to happen? Iodine is going to replace halogen X to give alkyl iodide and NOx. Here, we should note that fluorine is not going to, alkyl fluoride is not going to give this reaction. Why? Because this bond is strong. The carbon fluorine bond is strong, so it is not easy to break. The bond is strong because of smaller size of fluorine. Now, next reaction is for preparation of alkyl fluoride, that is known as Schwarz reaction. In Schwarz reaction, we take alkyl halide. Again, X can be chlorine or bromine. Here we take metallic fluoride or inorganic fluorides. Inorganic fluorides. Inorganic fluorides like AgF, Hg2F2, COF2 or SbF3. These inorganic fluoride can be used. Fluorine is going to replace halogen and we are going to get Rf and AgX as the side product. Next reaction is Wurtz reaction. In Wurtz reaction, what is going to happen? We have to take 2 moles of alkyl halide. For example, we can take CH3Cl. 2 moles. We are going to react these 2 moles with 2 moles of sodium in presence of dry ether. Dry ether is the solvent here, and it is important to take dry ether if we are going to take any aqueous or moist environment. The reaction product will change. So what is going to happen here? We will break this bond and 2Cl will combine with 2Na to give 2NaCl as the side product, and 2-methyl group will combine to give ethane. So ethane is the main product here. And here important thing is to note down that the alkyl halide we are taking, we get product as the double the number of carbon atom as we are taking in the reactant. Next reaction is Wurtz-Fittig reaction. In Wurtz-Fittig reaction, we have to take one alkyl halide and another halobenzene or haloarenes. So again, the reaction is same. R and A are going to combine to give alkyl benzene and NaX. Next is Fittig reaction. Like in Wurtz reaction, we take alkyl halide. In Fittig reaction, we have to take aryl halide. This is aryl halide. Aryl halide. So 2 benzenes are going to combine to give AR. This is known as biphenyl. AR is biphenyl. So You should also note that in exam you will going to mention the structure. These notes are the short notes. So please do not mention like ARAR. You will mention like this. Okay. Next reactions are Friedel-Crafts reaction. In Friedel-Crafts reaction, we have first alkylation. Alkylation of benzene we are going to discuss. In alkylation of benzene, we are going to take RX in presence of anhydrous AlCl3. So RX with anhydrous AlCl3, suppose I am taking RCl, alkyl halide. So alkyl halide reacts with AlCl3. AlCl3 is going to act as Lewis acid. Lewis acid is electron deficient. So what is the work of AlCl3? It abstracts the chloride ion. It abstracts the chloride ion and forms a electrophile. There will be production of electrophile which is carbocation here. Here electrophile is carbocation, and we know benzene is very good reagent in giving electrophilic substitution reaction. So R positive is going to attack on benzene, and we are going to get alkyl benzene as the product, alkyl benzene as the product, and side product will be HCl. If we are having chlorobenzene, if we are having chlorobenzene, so chlorobenzene, we should know Cl group. Cl group consists of lone pairs due to which it acts as ortho para directing. Ortho para directing. What is the meaning of ortho para directing? That means it gives the direction to the electrophile so that the electrophile can attack on ortho and para positions. Electrophile can attack on ortho and para position by providing ortho and para position as the negative charge. So here we are going to get two products. One product is going to be ortho substituted. This is R, not X. This is going to be R as well. So ortho product and para product. Ortho product is the minor product and para product is the major product. Ortho product is minor because of steric hindrance, and here it is major because of less steric hindrance. Similarly, if we have any group which is ortho para directing, that will going to produce uh, ortho and para product. Any group which is meta directing, that is going to produce meta product. So next reaction is acylation. So reaction is similar. Here we take acyl chloride. This group is acyl, and here we are taking chlorine, so it will become acyl chloride. The electrophile you should know. Here electrophile is RCO positive. So this acyl group is going to attack on benzene to give uh, carbonyl compound. Benzene with a carbonyl compound. And if we take chlorine, so we are going to have two products, one ortho product and one para product. Ortho is again minor and para is major one. In place of acyl chloride, we can also take an anhydride. Anhydride is also going to produce acyl as the carbocation. So important part in these reaction that we should know what is the electrophile. So let me know if this is clear to all of you or not. All the name reaction from alkyl halide and aryl halide we have discussed. Please let me know. Let me
Yes.
know if any query, any question.
No, sir.
Yeah. Okay. Okay. In just a second. Okay. Okay, let me read the chat. Just a second. Okay, very good, Arish. Okay, so there is a question why we are using CS2 as the solvent. CS2 is acting as solvent here. So we are basically doing this reaction in presence of a non-polar solvent. CS2 is a non-polar solvent. Uh, if we are going to use this reaction in polar solvent, so you can see there is oxygen. So oxygen can be affected by the polar solvent as this benzene, this is basically ether, alkyl phenyl ether. So this oxygen can be affected by the polar solvent, due to which we are using non-polar solvent. It won't be affected by the non-polar solvent. Clear? Okay. Now reactions from the, yes, yes, correct. You can also use that organic non-polar solvent. Okay, next reaction are from alcohol, phenols, and ethers. So the in alcohols, phenols, the next reaction is for phenols. This is very important reaction. For JE, this is important. Now, you have to take phenol reacted with CHCl3 in presence of aqueous NaOH. Okay, I am going to explain this with the help of mechanism. First of all, you should know about chloroform CHCl3, and you are taking it with a base. You can take KOH or NaOH. So what is going to happen here? This hydrogen of chloroform is acidic. Why this is acidic? Because presence of Cl. Three Cl groups are present which are highly electronegative and act as minus I group. So a base OH negative can remove H plus from chloroform, and this bond will move here, giving carbon a negative charge. Now, this step is going to occur simultaneously, but I am going to expand this. So suppose you are having carbon ion here, Cl, Cl, and Cl. As soon as this carbon ion is going to form, one chloride ion is going to remove. One chloride ion remove. So basically that will going to provide carbon a positive charge, but carbon is already having a negative charge. So that is going to neutralize, and we are going to have Cl, Cl. That is, sorry, not negative charge, two lone pair, because carbon is having 4 electrons, not lone paired, only 2 electrons. Carbon is having 4 electrons, out of which there are 2 bonds and 2 electrons are there. This is known as carbene. This is known as carbene. So carbene is the our electrophile here. Carbene is going to act as electrophile, not nucleophile. You should know. It is a electrophile. You will say how it is possible this is an electrophile, because we are having 2 electron here. So this is electrophile because you can see carbon is having how many electrons total? Two from these 2 electron and two from each bond. So there are 6 electrons. Total 6 electrons are there. Because of it, it is electrophile. Now, this carbene electrophile is going to attack on phenol. So we are forming the uh, product on the ortho position. As electrophile attack on the ortho position, we get CHCl2, and with the help of NaOH, this CHCl2, okay, I'm showing here the whole reaction. Next is phenol. Phenol reacts with NaOH. Uh, okay, we have taken KOH, so we can take KOH. So phenol is an acid. It is going to provide O negative, K positive. plus H2O. So this is potassium phenoxide. Here the important molecule is phenoxide. Important molecule is going to be phenoxide. Now, why phenoxide is important? Because this phenoxide ion is going to attack on carbene. How? This negative charge moves to carbon oxygen bond, and the double bond here is going to attack on the carbon. So we get double bond oxygen. One double bond of oxygen is going to break Cl, Cl. So benzene loses its aromaticity, which is not good for benzene. So what we will do, we are having hydrogen here. This hydrogen also, the carbon is going to get a negative charge. Because why negative charge? Because it is already having 2 electrons and 2 electrons move from the benzene. This negative charge is there on carbon, and the hydrogen, to provide the stability to the benzene, is going to uh, remove, providing double bond to the carbon, and this double bond oxygen is going to break. Also hydrogen H positive is going to remove, which is abstracted by the carbon ion. So we can see 3 steps occur simultaneously, and we get O negative, CH, Cl, Cl. This O negative from water is going to take H plus, or we can also show this step in the last as well. We can also show this step in at last as well. Cl, Cl. This Cl, Cl is going to react with KOH. So substitution reaction will be there. We will remove Cl and add OH, OH. Remove Cl, Cl, and will provide OH, OH, OH. So we get CH, OH, OH. Now, two OH on single carbon are highly unstable. From here, water is going to remove, and we finally get our desired product. Finally get desired product. That is, do you know what is the name of this product? Anyone knows what is the name of this product? Both name, IUPAC and the common name. Anyone know what are the name of this product? Salicylaldehyde,
Arysaldehyde.
salicylaldehyde, correct. And anyone know what is the IUPAC name of this compound? Because there is a question in JEE regarding the IUPAC name of salicylaldehyde. They have mentioned what is the name of salicylaldehyde. What is the IUPAC name
Alpha
of salicylaldehyde? Yes, yes,
hydroxybenzaldehyde.
correct, exactly correct. 2-hydroxybenzaldehyde. 2-hydroxybenzaldehyde. That is correct. Not one, not one. It is two, because CHO group is going to given the priority, and we will giving this carbon as the 1 and this carbon as 2. So it will become 2-hydroxybenzaldehyde. Okay. So, okay, you need not to write the full reaction as I have explained to you. It will be given in hardly 1 or 2 marks. So you will give this reaction only. You can give only this much of the reaction. That will also give going to provide you the full marks. There is a similar reaction to that, which is Kolbe's reaction. In Kolbe's reaction, we take carbon dioxide. We have to take carbon dioxide in place of CHCl3. So, do you know carbon dioxide is also act as electrophile? Can anyone let me know how carbon dioxide act as electrophile? 8 electrons are there, octet is complete. There is no positive charge. There is no vacant orbital, no vacant orbital. So how carbon dioxide act as electrophile? Anyone know how carbon dioxide
Sir,
act
if
as
an
electrophile?
extra lone pair is added, then it performs resonance.
Uh, Okay, because of resonance. No. Yes, yes, correct. Okay, you know, we deal in chemistry, will deal with movement of electrons. So, you know, oxygen is electronegative atom, due to which oxygen is having partially negative charge, both the oxygen, and this carbon center is having positive charge. So this carbon is electron deficient because of these two oxygen. So this is because of polarity. Carbon dioxide act as electrophile because of polarity. So if you can see the Ramer-Tiemann reaction, which is also known as RTR or Kolb's reaction, both are examples of electrophilic substitution reaction. Both of them are example of electrophilic substitution reaction. So here we get salicylic acid. Here we get salicylic acid as the product, which is 2-hydroxybenzoic acid. Next reaction is Rosenmund reaction. This is also important reaction. In Rosenmund reaction, what we will do? We have to take acyl chloride. Basically, this particular compound is benzoyl chloride. Benzene is having COCl, is known as benzoyl chloride. So this is basically a reduction reaction in which what we are doing? We are adding hydrogen in presence of PDBSO4. What is going to happen here? This COCl bond is going to break. H and H we are providing to get benzaldehyde. This is for the preparation of benzaldehyde, Rosenmund reduction or Rosenmund reaction. Next reaction is Stephan reaction. In Stephan reaction, this is also a reduction reaction. RCN, RC triple bond N. RC triple bond N, we need to break the carbon nitrogen bond to get aldehyde. This is for the preparation of aldehyde. So we take stannous chloride SnCl2. So you should know what is the reagent in Stephan reaction. SnCl2 plus HCl is the original reagent. Or you can also use Sn plus HCl. That is also going to do the same work. SnCl2 HCl, or you can take SnHCl. So what is going to happen here? One bond is going to break, one bond is going to break, and we give each carbon and nitrogen hydrogen. You can see CH double bond NH. This is known as imine. This is known as imine. And what is the next step? Next step is simply hydrolysis. Next step is the simply hydrolysis. What happens in hydrolysis? We have this RCH double bond NH. So on hydrolysis, we break this double bond. Now in hydrolysis, we know water consists of H plus and OH negative. So nitrogen is more electronegative atom. So we provide two H plus ion. We have to take two water molecule and two OH negative to the CH1. So here we have R, CH, OH, OH. This bond, you can say two OH on one carbon are unstable. So we get RCHO as the main product. So this is again the preparation of aldehyde with the help of Stephan's reaction. Next reaction is again preparation of aldehyde, aromatic aldehyde, which is known as Itard's reaction. In Itard reaction, we take toluene. Toluene is aromatic benzene with CH3 group. Chromyl chloride, CrO2Cl2. CrO2Cl2, chromyl chloride is the uh, reagent here that is going to react with alkyl benzene, and we get a complex intermediate. You can see this is the complex intermediate in which we are having CHOCrOHCl2. CHOCrOHCl2. Again, hydrolysis, because we are having 2 moles of it. So 2 OH on CH group will be there. That is ultimately going to produce CHO. So this is kind of part that you have to remember. There is no other way. There is only structure of this compound that I will let you know if you want to ask. But you have to remember this. You have to remember this only for the product formation. Yes, okay. This is Getterman-Koch reaction. This is also very important reaction and interesting reaction. This is also example of electrophilic substitution reaction. Basically, this is related to acylation. How? You know this carbon monoxide CO and HCl. When CO and HCl reacts, it is going to form HC double bond OCl. This compound is known as formyl chloride. This compound is known as formyl chloride. Formyl chloride, and in formyl chloride, we react formyl chloride with AlCl3. When formyl chloride reacts with AlCl3, so it will abstract the Cl part, and we will get HCO positive, formyl carbocation. This formyl carbocation attack on benzene to produce benzaldehyde. Formyl carbocation attack on benzene to produce benzaldehyde. Next reaction from aldehyde again, aldehyde ketone again, Clemmensen reaction. So this is again, you have to remember the reagent. In Clemmensen reaction, we remove the CO to provide two hydrogen on the carbonyl carbon. This happens in presence of zinc amalgam, then Hg. In presence of HCl, we get alkane as the product. So this is the reduction of carbonyl compound. There is similar reaction which produce the same product, which is known as Wolff-Kishner reaction, but the reagent is different, and this is two-step reaction. In that, we have to take NH2NH, NH2NH2. NH2NH2 is known as hydrazine that is going to produce with the help of KOH and ethylene glycol. So in first step, you have to use NH2NH2. In second step, KOH and ethylene glycol. What is ethylene glycol? CH2OH, and CH2OH is known as ethylene glycol. So that is again going to produce alkane. Alkane is the product here. Now from aldehyde and ketone, the test part. So in test part, probably there will be no question to write the equation, but this is important for the JE part. So what you have to remember here, there are two things. First of all, you should know what is Tollens reagent. Tollens reagent is ammonical silver nitrate. So this AgNH32, there is also going to be a positive charge here on the complex AgNH32, that is our required Tollens reagent. And this is RCHO aldehyde. When it reacts with Tollens reagent, it produces carboxylic acid ion. So basically, this is oxidation reaction. Tollens reagent is a mild oxidizing agent that converts aldehyde into carboxylic acid salt. How we are going to know this is a oxidation reaction? You can see CHO is converting into carboxylic acid salt, that is oxidation. And also they can ask you the change in oxidation number of Ag. If you determine the oxidation number of Ag, it is Ag plus, and it is converting into Ag. This positive charge is for the reaction part, like plus H2O and NH3. So it is converting into Ag. So this is reduction, gain of electron. So Tollens reagent is acting as an oxidizing agent because the reduction is occurring for that Tollens reagent. Another reagent which do this similar work is Fehling solution. In Fehling solution, we have two solutions: freshly prepared Fehling solution A, Fehling solution B. In Fehling solution A, we have aqueous copper sulfate, and in Fehling solution, we have alkaline sodium potassium tartrate, which is also known as Rochelle salt. So this is nothing but both these compounds are going to produce copper 2 plus. This is the main reagent. Copper 2 plus is the main reagent. Copper 2 plus is, you know the color of copper 2 ion. or you can say copper sulfate, which is blue. When reaction is going to occur, again the oxidation is going to be there. It produces Cu2O. The color of Cu2O is red brown color or brick red color. This is red brown or brick red color. So ultimately you should know that copper 2 plus is going to convert into copper plus, copper ion. That is again a reduction reaction. That is again a reduction reaction. So reagent is also going to act as Failing reagent is also going to act as oxidizing agent. More reactions from aldehyde and ketone. The next reaction is aldol reaction. So to understand aldol reaction, we have the conditions for the aldol reaction. The first condition for the aldol reaction, there must be presence of alpha hydrogen on carbonyl carbon. What is carbonyl carbon? This CO is known as carbonyl carbon, and if we add some carbon on the carbonyl carbon, so we can count it like this. This is the reference CO. This will act as alpha. This is beta and this is gamma. Similarly here, alpha, beta, gamma. So any hydrogen on alpha carbon is act as alpha hydrogen. Similarly here, this is also alpha hydrogen. So alpha hydrogen presence is must, and second condition is dilute base. Dilute NaOH or KOH we have to take. So how the reaction proceed? We have to take 2 moles of any carbonyl compound which consists of alpha hydrogen CH3CHO. We react it with OH negative. So there can be 2 types of question to complete write the product, or there can be question explain the mechanism. So mechanism is first step is to obtain a carbon ion which act as nucleophile. So we have this base and this 1 mole of acetaldehyde. The hydrogen is acidic, so it produces a carbon ion which is this one CH2 CHO. It is going to act as nucleophile. Next step is nucleophilic addition reaction. The other molecule of CH3 CHO, we are going to write it like this COH. Now nucleophile CH2 negative CHO attacks on carbonyl carbon. 5 bonds will be there. 1 bond is going to break. So we get CH3 CO negative H CH2 CHO. This O negative from there will be solvent water. So it take H and finally we get the desired product CH3 CH OH CH2 CHO. This compound, you can see this is alpha, this is beta. This compound is basically beta hydroxyaldehyde. Beta hydroxyaldehyde. This is the common name, not the IUPAC name. IUPAC name will be 3-hydroxybutanol. Beta hydroxyaldehyde. 3-hydroxybutanol is the IUPAC name. And these 2 steps combinedly are known as aldol reaction. These 2 steps combinedly are known as aldol reaction. And if we heat this compound, if we heat this particular compound, then the reaction become aldol condensation. In condensation, there will be removal of a small molecule. So if we heat this, how we are going to heat this? We are going to write this compound like this. OH and H will be there and CHO. On heating, what is going to happen? Water is going to remove and we get CH3 CH double bond CH CHO. So again, this is alpha, this is beta. Alpha beta consists of a double bond which is unsaturation. So this is known as alpha beta unsaturated alpha beta unsaturated aldehyde. So now the reaction becomes aldol condensation. 3 steps aldol condensation, 2 steps aldol reaction. So currently we have discussed the self aldol where we have taken the two similar reagent like this one CH3CHO. So it will going to produce only one product. And if we using two different aldehyde or ketone, in that case we are going to have 4 products. In that case, we are going to have 4 products, CH3CHO like ethanol and propanol. These going to produce 4 products. So we have to follow the same mechanism to obtain the product. There will be no question to form all the product from two different aldehyde. You should just know there will be 4 products. Next reaction is Cannizzaro reaction. In Cannizzaro reaction, the conditions are reversed. The conditions are reversed in the just a second someone okay in Cannizzaro reaction conditions are reversed. There must not be no alpha H. There should not be any alpha H. Concentration concentrated alkali must be there. Concentrated NaOH or KOH we have to take. And this reaction is also a disproportionation reaction in which single product is going to convert or same product is going same reactant is going to convert into oxidized and reduced product. There will be simultaneously oxidation and reduction in the same reactant. You can see this is HCHO formaldehyde with no alpha H. This HCHO is converting into salt of carboxylic acid. So this reaction is oxidation. This particular reaction is oxidation. And another molecule of HCHO is converting into alcohol, CH3OH. So this particular reaction is reduction. So both oxidation and reduction reaction is going to occur simultaneously. That's why this is known as disproportionation reaction. If we are having benzaldehyde, so benzaldehyde also give the same reaction. Oxidized product, sodium benzoate, and reduced product, benzyl alcohol. What if we take two different aldehyde or aldehydes like I am taking HCHO and PHCHO. PHCHO is benzaldehyde. So in that case, if we are taking concentrated alkali, what is going to happen? So we should know a more reactive aldehyde will going to oxidize and less reactive will reduce. Formaldehyde is more reactive than the benzaldehyde. So formaldehyde will convert into HCOO negative, and there, suppose I am taking a KOS, so K plus will be there in place of H, and PHCHO will convert into PHCH2OH. So this is oxidation and this is reduction. Now this is not disproportionation because we are taking two different reactants. This is cross Cannizzaro. This is example of cross Cannizzaro reaction. Okay, Kolbe reaction is related to class 11. This is not important for class 12 boards, but it can be asked in JEE. So we can discuss it later on because we are currently focusing on the boards. Next is from carboxylic acid, Held-Volhard-Zelensky reaction, HBZ reaction. In HBZ reaction, we have to take any carboxylic acid which consists of alpha hydrogen. For example, this one RCH2CHO. Here we have alpha hydrogen, 2 alpha hydrogen. We react this compound with halogen in presence of red phosphorus. We can take here chlorine or bromine as the halogen, X2 red phosphorus. Hydrogen is going to replace by X and we get alpha halocarboxylic acid. Alpha halocarboxylic acid. We can react this compound further with X2 and red phosphorus with water. So the another H is also going to remove. We get CX2COOH. So we get 2 halogen. So whatever be the number of alpha hydrogen, they are all going to replace one by one. Now from the amines, the reaction is Gabriel-Thalamide reaction. So this thalamide is important. How you can produce thalamide, I will show you in short. You are having phthalic acid. This is phthalic acid. When we strongly heat phthalic acid with ammonia, when we strongly heat phthalic acid with ammonia, water is going to remove. Water molecule is going to remove, and we get CONH, CONH. You can see here CONH, CONH. This H is acidic in nature. This H is acidic, so it react with base, and there will be formation of N negative, K positive. N negative, K positive. Uh, N negative is nucleophile that attack on R. N negative is the nucleophile that attack on R, and removal of X will be there to produce NR. Now, what we are going to do? We are going to hydrolyze this with the help of NaOH, basic hydrolysis. So there will be two hydrogen on nitrogen, and we get RNH2. RNH2. So this is primary amine. This product is the primary amine. We can only produce primary amine with the help of Gabriel-Thalamide reaction. There will be no secondary or tertiary amine produced with the help of Gabriel reaction. This is also important for amines. Next reaction is Hofmann bromide reaction. So Hofmann bromide reaction, you should only remember the reagent. The reaction is very simple. You have this amide. Amide in presence of bromine and NaOH. Amide in presence of bromine and NaOH. CO is going to remove. This is amide. Remove CO. Amide is going to convert into RNH2. Primary amine. Amide is going to convert into primary amine. So you should only remember the reagent and product. Side products are sodium carbonate, NaBr, and H2O. For amines, there is very important reaction which is carbyl amine reaction. Carbyl amine, or also known as isocyanide test. This RNH2 primary amine reacts with chloroform with KOH to produce RNC, alkyl isocyanide KClH2O. So in exam they can ask you the reaction of methane amine with chloroform KOH. So you are going to form CH3NC. This CH3NC is methyl isocyanide. Methyl isocyanide is the gas which is being leaked in the Bhopal gas tragedy. This is highly poisonous gas. Tertiary, secondary and tertiary amine cannot show this reaction. Only this is for the primary amine. Only for the primary amine. To distinguish primary, secondary and tertiary amines, what we will be doing? We will be doing Hinsberg test. So probably this question is not going to ask in the board examination, but you should know how the reaction proceed and what is the Hinsberg reagent. So this is to distinguish primary, secondary and tertiary amines. Hinsberg reagent is benzene sulfonyl chloride. What is benzene sulfonyl chloride? Benzene, this SO2Cl. This is known as benzene sulfonyl chloride. So suppose we are reacting benzene sulfonyl chloride with primary amine like ethanamine. So C2H5NH2. What is happening here? You have to remove HCl, and there will be bond between sulfur nitrogen. So there is a bond you can see. Now this hydrogen is acidic in nature. Due to acidic nature of this hydrogen, it is soluble in alkali. This is soluble in base. Now if we react it with secondary amine, in secondary amine, we are going to have only one hydrogen. So we get S bond N. Now there is no hydrogen. There is no hydrogen or nitrogen. So this compound is insoluble in alkali. This compound is insoluble in alkali. And in tertiary amine, there is no hydrogen or nitrogen. So first step is not possible. So tertiary amines do not react with benzene sulfonyl chloride. Primary amine reacts with benzene sulfonyl chloride and the product is soluble in alkali. Secondary amine reacts with benzene sulfonyl chloride and the product is insoluble in alkali. And tertiary amine is not going to react with benzene sulfonyl chloride at all. Okay. Okay, next reaction is coupling reaction. In coupling reaction, we have to take benzene diazonium salt, and there are two reactions. First with phenol. So para hydrogen of phenol is react with diazonium salt. Removal of HCl is there, and there is a N double bond N is there. N double bond N is there. So this N double bond is azo. Due to this N double bond N, this group is known as azo. This is known as para hydroxy azobenzene. Para hydroxy azobenzene. And this reaction is helpful in for the dye. These compounds are dye. Basically, when we are having OH phenol, so it gives us orange dye. This is the orange color compound. And if we use NH2, so that compound will be not para-hydroxy, para-amino-azobenzene, and this particular compound is yellow in color. This compound is yellow in color. Okay. So with this, all the name reactions are complete from organic chemistry. All of these are the name reaction. So we have revised all the name reaction. If anyone is having any query, any doubt, they can ask me now. Yeah, I will share you this PDF. Uh, sure. No, it won't work with ketones. Tolerance test, not going to work with ketones. What I will do, I will ask the support team to share the entire notebook, because here uh, all the short notes are there. For example, for haloalkanes separately, alcohol, phenol, ether, aldehyde ketones, amines, the important common names of the organic compound, for solution, for electrochemistry, for chemical kinetics, D and F block, and coordination compound. So I will ask the support team to share the entire notebook with you so that you can have the benefit of this. Okay. Anyone is having any doubt, you can ask me now. So Mr. Arish, how's the preparation? Okay, then. Thank you, everyone. Thank you. Thank you for your time.
Thank you, sir.
Thank you, sir.
Please check the calculations if they are all correct. 15 minus 7, that's 8. Indeed, it is 8. Right. And 8 square, that is also correct. 128. 8 divided by 128. So 48. 8 divided by 48. 16. That is correct. And No, I don't think there is any problem over here. Everything is correct, everyone. Seems to be correct. Okay, good. So now, everyone, these are the important questions of arithmetic progressions and quadratic equations, right? Now, observe the rest of the 5 markers are going to come from which chapter? It is going to come from triangles. Okay. It is going to come from statistics. Okay, which is very easy. If you do the NCERT, more than enough. Okay. Over here, do the NCERT plus exemplar for triangles. Okay. And the third thing is what? The third thing was just a second. Let me check. There was one more chapter.
Application of trigonometry.
No, 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 no. Application of trigonometry has a very less chance. It can come from applications of trigonometry. Application of trigonometry will have a question in that what do we call value-based questions. Most probably it is going to come from value-based. Okay. So anyway, let's observe surface areas and volumes. Okay. This is as per the latest CBSE sample paper. Okay. And most of the sample papers that are built are upon that only. And this particular thing that I have analyzed is from that sample paper only released by CBSE in the month of October, I guess. Right? For surface area and volume, just do the NCERT. Okay. And if you can do the exemplar, well and good. Even